Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael C. Ndinechi. Our topic today is radio receivers. Over the years, different types of radio receivers have been designed. Of all of them, only two are very common and have been of commercial value, and they are the tuned radio frequency TRF and the superheterodyne receivers. These early radio receivers had poor performance compared to the ones in use today. With advances in technologies like digital signal processing DSPs and high performance semiconductors, very high performance radios are now common. They range from the more traditional broadcast radio receivers to the professional communications receivers. In addition, increase in cellular and wireless communications has meant that there are many different receivers needed for different applications. In view of this, many different types of radio receivers abound. However, we will be limiting ourselves to the TRF and the superheterodyne ones. This type of tuned radio receiver was used in the first generation of receivers and consists of a tuned circuit and a detector. Tuning was provided by a combination of tuned coils and capacitors, and the signal presented to a simple diode detector where the modulated signal is recovered. Typically, the TRF receiver consists of three main sections as shown in Fig 1. We have the first and second stage radio frequency amplifiers and the detector stage ganged. Then the output is fed to the power amplifier, then to the output device. The stages. The first stage, the radio frequency stage, this consists of two or more radio frequency amplifying and tuning stages, all ganged to select and amplify the incoming frequency and simultaneously to reject others. The signal detector stage, after the signal might have been amplified to a stable level, it will be fed to the detector stage. The detector enables the information signal from the modulated signal to be extracted. Power amplifier stage. The power amplifier provides the amplification to the required level to drive the output. Operation of the TRF. TRF receivers were popular in the 1920s as it provided sufficient gain and selectivity and was easy to design and align at broadcast frequencies, but presented some difficulties at higher frequencies. The TRF receiver suffered from variations in bandwidth over the tuning range. As a result, it was unable to achieve sufficient selectivity at high frequencies. This was partly as a result of the enforced use of single-tuned circuits. However, attempts were made to overcome these problems by the introduction of the Ferranti models of integrated circuit chips. Other commercially available ones include MK484 and so on. The problem of instability, insufficient adjacent frequency rejection, and bandwidth variations in the TRF are all solved by the use of the superheterodyne receiver. One of the most common forms of radio receivers is the superheterodyne radio receiver, simply called the superhet. Virtually all broadcast radio receivers, AM, FM, SSB, etc., as well as televisions, radar systems, and other commercial radios operate on the superhet principles. Although more complicated than some other forms of radio receivers, The Superhet offers many advantages in terms of performance, particularly in selectivity. The Superhet block diagram is as shown in Fig 2. You can see the RF stage, the mixer, all ganged with the input from the local oscillator. Then the output is fed to the IF amplifiers, then the detector stage, power amplifier, and to the output. The stages, the tune radio frequency stage. This stage provides the initial tuning to remove the image signal. The radio frequency circuit is used mainly to select the wanted frequency, to reject interference such as the image frequency, and to reduce the noise figure of the receiver. The LO stage. The local oscillator stage can be of free-running type multivibrator or frequency synthesizers, normally the phase lock loop, PLL type. The local oscillator provides much greater levels of stability and enable frequencies to be programmed in a variety of ways. Mixer stage. The incoming signal of the output of the local oscillator are multiplied in the mixer section to convert the wanted signal to the intermediate frequency. The intermediate frequency stage provides the majority of gain and selectivity needed for optimum performance. The demodulation stage. This stage extracts the information-bearing signal from the baseband signal. Once demodulated, the recovered signal is applied to the power amplifier to be amplified to a level that can drive the output device. Principle of operation of the Superhet. Signal from the antenna is fed to the RF amplifier where they are tuned to remove the image signal. The signal is then applied to the mixer along with the local oscillator output where the wanted signal is converted down to the immediate frequency. Here, significant levels of amplification are applied and the signals are filtered. The advantage of IF filter over RF filtering is that the filter can be designed for a fixed frequency. This allows for much better tuning. Once filtered, the signal is fed to the demodulator. This could be for amplitude modulated, single sideband, FM, or any other form of modulation. It is also possible to switch different demodulators in accordance to the mode being received. The final block, which is the power amplifier, amplifies the signal to a level stable to drive the output device. The Superhet operates by mixing the incoming frequency with a locally generated signal to convert it down to a frequency where the required signal can be extracted via filtering. Mixing in this context is nonlinear, that is, frequency multiplication that enables frequencies to be changed or translated. Other receivers in use. 1. Regenerative receivers. Regenerative receivers significantly improve the gain and the selectivity obtainable. They use positive feedback and operate at the point just before oscillation occurs. In this way, significant multiplication in the level of quality of the circuit is obtained. They are only useful for AM, SSB, and MOS receptions. Super regenerative receivers. The super regenerative radio receiver takes the concept of regeneration a step further, thereby achieving gain levels of over 1 million times. However, their use is still limited. 3. Direct conversion receivers. This type of receivers convert the signal directly down to the baseband frequency and is widely used in digital communications. It is widely employed in phase shift keying and quadrature amplitude modulated signals. Definition of terms. In the course of dealing with receivers, some terms are very necessary that we know. One, sensitivity. The sensitivity of a superheterodyne radio receiver is its ability to amplify weak signals. It is often regarded as that voltage that must be applied to the receiver input terminals to give a standard output power. Sensitivity is expressed in microvolts or in decibels below 1 volt. The most important factor determining the sensitivity of a superhertz receiver are the gain of the IF amplifiers and that of the RF amplifier. Selectivity. This is the ability of the receiver to reject unwanted adjacent signals. Image frequency rejection. In a standard receiver, the local oscillator frequency is made higher than the incoming signal frequency. It is usually equal to the signal frequency plus the intermediate frequency. Thus, F0 is equal to Fs plus F1, Fi, or Fs is equal to F0 minus Fi, where F0 is the local oscillator frequency, Fs is the signal frequency, and Fi the intermediate frequency. When F0 and Fs are mixed in the frequency changer, that is a mixer, the difference frequency, which is one of the byproducts, is equal to Fi. It is only this frequency which is passed and amplified by the IF stage. If a frequency, say Fu, manages to reach the mixer such that Fu is equal to F0 plus Fi, that is, Fu is equal to Fs plus 2Fi, then this frequency will also produce Fi when mixed with F0. Unfortunately, this spurious IF signal will also be amplified by the IF stage and will therefore cause interference. This has the effect of two stations being received simultaneously and is undesirable. Fu is called the image frequency and is defined as the signal frequency plus twice the intermediate frequency. Image frequency rejection depends on the front-end selectivity of the receiver and must be achieved before the IF stage. Once this spurious frequency enters the first IF amplifier stage, it becomes impossible to remove it from the wanted signal, and two stations will be heard at the same time. Thank you for listening. Please like, share, and subscribe. Drop your comments, questions, or topic you want me to lecture on in the comment section.